Distillation is a technique that is used to separate mixtures of liquid components based upon their boiling points. Distillation is performed industrially in large fractionating columns, but in the typical lab scale it is used to purify products, to aid in drying solvents and reagents, and to purify or prepare starting materials. In this particular experiment, we will be employing fractional distillation to heat dicyclopentadiene until it undergoes a retro-Diels-Alder reaction, thermally cracking into the two constituent cyclopentadiene monomers. Cyclopentadiene has a significantly lower boiling point than dicyclopentadiene, and can therefore be collected as a fraction from the distillation apparatus. Identity and purity of the distillate may be maintained via careful monitoring of the heat and the temperature at the distillation head. This distillate will then be added to a solution of maleic anhydride in ethyl acetate and hexanes, undergoing a forward Diels-Alder reaction. These react to form the kinetically preferred endoproduct that we will isolate and analyze. For this particular experiment, you will need quite a lot of glassware, and will be performing the distillation with your hood partner, as you will need two condensers for this setup. You will need a distillation collection adapter, with or without the vacuum adapter, a 3-way distillation head, two condensers, thick or thin is fine, a glass and Teflon thermometer adapter, mine is black but yours may be a red-brown color, a thermometer, a 100 ml graduated cylinder with a septum that fits into the top, a 100 ml round bottom flask, a heating mantle, thin-walled tubing, thick-walled tubing, a 10 ml graduated cylinder, a funnel, pictured here is a powder funnel, but I ultimately add the small plastic funnel to my setup as well, a spatula and or scoopula, a 25 ml Erlenmeyer flask, a 25 ml filtration flask, and a Hirsch funnel. Not pictured are a watch glass for your final product, and a crystallizing dish plus half petri dish for ice baths. While performing a distillation, all joints should be well greased to ensure a good seal and to help prevent the pieces from getting stuck together while you're trying to dismantle them. Like the stopper for your separatory funnel, add a small amount of grease to the male end of whatever glassware is being joined, and rotate until it rotates smoothly and the joints look translucent. It may be useful for you to lay out all of the distillation glassware as will actually fit together to make things simpler for yourself. We will first assemble the distillation part of the apparatus and ignore the round bottom flask and fractionating column for the moment. Join the 3-way distillation head to the condenser and use a rubber band to help seal the joints. Double over the rubber band for it to have a good taut fit. I would recommend connecting everything with the water inlet/outlet facing down, as it will make plumbing the water lines easier and then you'll have to fight gravity less during the actual distillation. Now, connect the collection adapter to the condenser in the same fashion as the 3-way distillation head. Next, we will actually plumb the water lines. Using the clear tubing connected to the faucet in the back of your hood, connect the water line to the inlet or lower nub on the lower collection adapter side of the setup. This will give a smoother flow profile and allow for more efficient cooling of the distillate. Parafilm this for a good seal and to help prevent leaks. We will now repeat this with the thin-walled tubing in your blue bins on the outlet side of the condenser. Note that I loosely connected a boss head, or clamp holder, to the other side of this tubing. This will help to keep it in the sink should the water pressure change. This next shot is simply obtaining the dicyclopentadiene. As this reagent is an inhalation hazard, be sure to only pour it into your graduated cylinder in the distribution hood. Once you have obtained the 20 ml of dicyclopentadiene, loosely cap the graduated cylinder with a large septum to reduce exposure. Now we are ready to complete our setup and begin to crack our dicyclopentadiene. If you have not yet checked the calibration of your thermometer, be sure to do so. A beaker of boiling water in the distribution hood may be used to check whether it reads within 5 degrees Celsius of the boiling point of water. If not, obtain a new thermometer from the stockroom and check it. Clamp your 100 ml round bottom flask above the stir plate and nestle it into a heating mantle. Make sure that it is well clamped, as this will be the main anchor point of your setup. Add the dicyclopentadiene, a stir bar, and place the fractionating column on top of the setup. Next, to your actual distillation apparatus, connect the glass and Teflon thermometer adapters. Insert the thermometer into the apparatus and note the placement of the bulb. It should be just below the junction of the three-way distillation head to ensure it's properly bathed in saturated vapor and reads the temperature of the distillate accurately. Use another clamp to lightly support the condenser and anchor the distillation apparatus to the scaffolding in the fume hood. For collection of the distillate, you may need to try several setups to easily collect into a 10 ml graduated cylinder, depending upon how vertically your setup is standing. Here I ultimately settled on a single blue bin from the cabinets and an iron ring to hold a powder funnel above the graduated cylinder. Once the distillation begins, I add a small plastic funnel to help with collection. You may try using the blue box from your cabinet or adding a second blue bin if your setup is a little taller than mine. If it's shorter, using a beaker to elevate the crystallizing dish instead of the blue bin may be helpful, or using the beaker as an ice bath instead of the crystallizing dish. With everything set up, you may now turn on the water. Turn it on slowly so that there isn't a sudden bump in pressure. Adjust the flow rate until the water is flowing both quickly and smoothly. If you can't tell if it's flowing or not, touch the condenser to see if it feels cool. Next, turn on the stirring, approximately 300 RPM, and connect the heating mantle to the silver varistat outlet. Turn the varistat to approximately 75 or 80% power and allow it to begin to heat. Within 10 or 15 minutes of turning on the heat, you should see the dicyclopentadiene begin to yellow a bit and to begin foaming. This is normal. It is likely that you will need to insulate your fractionating column with a piece of aluminum foil so that it stays warm enough for your cyclopentadiene to make it to the condenser rather than refluxing and condensing back into the round bottom. You may need to add an additional piece of foil to the top of your round bottom to help keep everything hot. You may also need to increase your varistat power if insulating isn't sufficient. Monitor the temperature at the distillation head and maintain a temperature range of 40 to 50 degrees Celsius to obtain a reasonably pure product. After heating and distilling for an hour and collecting at least 1 ml of cyclopentadiene, you may remove the setup from heat and allow it to cool down. If you haven't collected at least 1 ml of distillate, speak to your TA and you may share within the bay to get enough cyclopentadiene. If your cyclopentadiene looks cloudy, dry it over a small amount of anhydrous sodium sulfate for 5 minutes in a small beaker or Erlenmeyer flask to remove residual water. While your distillation apparatus is cooling, add 500 milligrams of maleic anhydride to a 25 ml Erlenmeyer flask. To this, add 2.5 ml of ethyl acetate and dissolve the maleic anhydride. Here I used a stir bar, but you may swirl or use a glass stir rod if you'd like. Once dissolved, add 2.5 ml of hexanes to the solution and cool it in an ice bath. The distillation setup should be well cooled now, so you can use the stir bar, clean it first, from this if necessary. Once the maleic anhydride solution is cool, add the cyclopentadiene to begin the reaction. You may use as little as 0.5 ml depending upon the amount of distillate recovered. Here I used 1 ml of cyclopentadiene. Allow the reaction to stir in an ice bath. Make sure you elevate it on a half petri dish for at least 10 minutes, or at least until you need to clean up if you're running out of time. Remove the stir bar, seal the Erlenmeyer flask with a septum and parafilm, and store in your drawer until the next lab period. For this reaction, we will recollect any dicyclopentadiene remaining in your round bottom flask. Lightly seal the round bottom with a stopper or septum and take it over to the distribution hood. You will see a container for recollection of the dicyclopentadiene to be purified for later use. Please do not use acetone, water, etc. to wash any residual dicyclopentadiene into this container. In the second lab period, you will briefly recrystallize your product. You'll learn more about recrystallization in the next chapter. Isolate the product, weigh it, prepare NMR and IR samples, and take a melting point. To your Erlenmeyer flask, add a stir bar and place it on the hot plate. Begin stirring the reaction mixture and heat the flask gently until all of the product dissolves. Remove the stir bar and allow it to cool to room temperature. Crystals will likely begin to grow at this point, but if not, that's okay. Transfer it to an ice bath for 10 minutes to help fully crystallize the product. After at least 10 minutes, isolate the product via vacuum filtration. We will use the plastic Hirsch funnel for this rather than using the Buchner funnel. Check that there is a filter frit in place and that it looks clean. If the frit is missing or appears dirty, replace it with a new one from your TA. The old frit may be removed by poking it out with a boiling stick and may be disposed of in the trash. The new filter frit should be simply pushed into place. Make sure that it is completely pushed into place before use. Vacuum filter to isolate your product. You may be able to transfer all of your product into the vacuum filter by scraping with a spatula, but if not, cool some additional 1:1 ethyl acetate hexanes mixture to help transfer everything. Allow your product to dry in the vacuum for a few minutes and transfer it to a pre-weighed watch glass. You may now prepare NMR and IR samples and take the melting point of your product. That's it for this video, so I'll see you in the next one. See ya.